720 a.m. in Las Vegas. Our show is produced by Green Alliance of Nevada, sponsored by NV Energy. I'm your host, Stan Hanel, with our producer, Annette Bubak, in studio today. And we've been talking today about taking kind of a deeper dive into jargon and terminologies associated with electricity primarily, but also how that applies to renewable energy, to energy efficiency applications, and to electric vehicle industries as well. If listeners have questions or comments, please call in. Our number at KDWN 720 AM is 702-257-5396. That's 702-257-5396. We're also being filmed for broadcast on video through Facebook Live. And Facebook Live audience can also text and write some questions in during the broadcast as well. So we had been talking about in electricity some of the terms, the water analogy, that electrons flow like a water current, the pressure from the water that's running through a pipe, in electric terms, we call that voltage. And then we have, if you have a valve or something, we have variable resistors that can regulate the flow of the electron current through circuits. And when they encounter a device that can do work, like an LED that can light up a light, or a motor that can spin a pump, that's the power that's generated by the combination of voltage and current. And so there is actually a formula for that we call Ohm's law for DC currents. That's voltage equals current times resistance. And then power also has a formula, power equals current times voltage. So there's these relationships that people can use to engineer these systems so that they work well, from all the way from great big generation and transmission systems such as our utility grid, all the way down to the microchips in our cell phones. So it's an amazing world that we live in now, and we've got all these things going on. We were talking a little bit about the war of the currents between Edison and Tesla, two geniuses that kind of clashed in trying to develop the standards for the utility grid. Basically, which they use, should it be all direct current or should it be alternating current? And those were the big clash of that time. And Edison kind of went, I think, over the line in trying to push DC current. In fact, he definitely wanted to badmouth AC and just really point out how negative it was, how dangerous it was. And even though it had all the benefits of being able to transmit and move electric currents over longer distances. And so he basically started a propaganda campaign that was trying to show how bad it was. In fact, at that time in New York, the electric chair was being created, and he made sure that people saw that they were using a Westinghouse generator developed by Tesla to actually kill people. And so also there was a man by the name of Harold Brown that was doing demonstrations with electricity, AC current, to show that he could kill dogs and hurt animals that way. So that was trying to spread this negative feeling about alternating current. To combat that, Tesla would give public demonstrations where he would basically create sparks through his fingers and out the other side. He'd usually be standing on a rubber mat, and he took precautions not to hurt himself, but he wasn't afraid to show that people shouldn't fear this electricity and this phenomena. In addition to in competition to Edison's light bulb, Tesla was one of the experimenters that worked on the fluorescent lamps, which were a different type of light bulb that actually used alternating current to light up gases in a fluorescent bulb. So there were different solutions that both men had and were championing, and it was a real battle there for a while. Both of them kind of came out on the losing end. In order to keep the company alive, Westinghouse was running into financial problems, so Tesla gave up the rights, the money that he was due for his patents on the Tesla polyphase system. In the end, Edison wound up selling his Edison Electric Company to another company that started to incorporate AC technology. So DC current is still used for low voltage applications, but alternating current eventually did win out in the war of the currents. So that's where we are today. It's generated for a long time. They used steam to spin a turbine, spin a magnet generator that would, or alternator that would create electric current, that would go over a transmission line many miles and then come to a substation where it would be kind of stepped down and then sent out to the houses of the local neighborhoods. There's local transformers in each neighborhood, and then lines that run to each home to light all our appliances and keep us plentifully supplied with electricity all year round. And even during the hottest days of the year, when our need for air conditioning goes way up, and our electric bills also kind of double or triple sometimes, because we really need that to survive out here during the summer. So basically, when you do get your energy bill, usually you see these terms, watts, kilowatts, or kilowatt hours, and I know we were kind of talking about the difference between those two.
Right.
Right.
Well, and we were also talking about how many of us don't even know what that is. I mean, I've spoken to groups of 100 people plus and asked for raise of hands. How many of you know what a watt is, or a kilowatt is, or kilowatt hour? And very few will raise their hands. Or, when you're reading your NV energy bill, right, how many of you know how many kilowatt hours you actually are using
right.
and over a year's time? And very rarely do you have somebody that actually understands how we're paying for energy, how energy is being delivered to us, and how it all ties into. So I'm glad that we're really diving into these subjects. I think it's incredibly educational.
Thank you very much. Yeah, and so as we talked about, kilowatts are 1,000 watts. They're increments of 1,000 watts, and that's a definition, a measurement of power consumed. But if you use power over time, that's more like energy. So you see kilowatt hours used as your consumption. How much power did you use over how long? And when you do get your bills, it's usually your meter reading, so many kilowatt hours for that month, and then you're assessed anywhere from 11 cents per kilowatt hour. If you have special rates, time of use rates, you might be only 5 or 6 cents at some time, maybe 24 cents a kilowatt hour during the summer. So there are that's one usage of it. But when we talk with our guest speakers on renewable energies, kilowatt hours are also used to define the amount of energy inside a battery. So energy storage is becoming a new industry that's popping up in the state. And also when somebody buys an electric car, what is the capacity of the battery? So a Nissan Leaf will have a 24 kilowatt hour battery pack, whereas a Tesla Model S might have a 100 kilowatt hour battery pack. The Tesla can go 300 miles, the Leaf can go about 100, 120, something like that. So basically the size, the amount of energy capacity in a battery is measured in kilowatt hours. So when you hear that term, 24 kilowatt hours, that means it can dispense 24 kilowatts of power in 1 hour, or it could dispense 12 kilowatts of power in 2 hours. It's kind of relational. They multiply together to get your total. So, or even you could do 6 kilowatts over 4 hours before you'd have to recharge your battery. So those are all numbers that kind of help. And then also just in terms of kilowatt usage, when you're recharging an electric car, we measure the amount of capacity of a charging system by how many kilowatts it can send of power to the car, voltage and current combined, to recharge a battery pack. So we have different standards. AC level 1 is about 3.3 kilowatts normally. AC level 2 about 6.6 to 7 kilowatts normally. And DC fast charge gets up to 50 kilowatts, even 100 kilowatts in charging system, about 8 to even 10 times faster. So,
which is the difference in how much time it's going to take to charge your battery if you're traveling or if you're home or whatever it may be.
And so normally we haven't had to use those kind of calculations before. We know a lot about gas and gas tanks and how much a gallon and all that. So we may be seeing some transitions around our home and things, and being able to understand this a little bit better in the future.
Pretty exciting.
Okay, we'll be right back. Thank you.
Thank you.